Hello students, welcome back to my YouTube channel Data Shop. In today's lecture, we'll be talking about p-values for the z-test. What is a p-value and how we can calculate it for different alternative hypotheses. So it's the smallest level of significance that would lead to the rejection of the null hypothesis. It is the observed significance level. So significance level is always given in the exam, and it is denoted with alpha. So in the last lecture, we have already done about the null hypothesis and the alternative hypothesis and how we can reject and accept our hypothesis. So let me just write down. So this is our two-tailed alternative hypothesis, and as you could see, this is the rejection region, and the critical values is z minus z alpha by 2 and z alpha by 2. So that's what is alpha. Whenever I am writing that this is my region 1 minus alpha, so alpha is the significance level, and 1 minus alpha is always your acceptance region, and alpha is your rejection region. We have already done that, how to calculate the alpha error in the last lecture. So that's everything is interrelated. Now the p-value, as you could see here, it is the smallest level of the significance that would lead to the rejection of the null hypothesis. So uh, if the level if the p-value is less than equal to alpha, then we reject the null hypothesis, and if it is greater than our alpha, then we'll be accepting our we fail to reject the null hypothesis. So let us consider how we could find out the p-value for the z-test. So we'll be considering all the alternative hypotheses. So if the test statistic is our z, and it has the standard normal distribution, then the p-value for the z-test can be calculated by, I'll write h1 here, and this is my p-value, the formula. So in the first case, h1 is left tail. For the left tailed, when we say that mu is less than mu naught, then in this case the p-value is calculated by the probability of z less than equal to z observed. So when we are saying that z is less than equal to z observed, I'll just draw the diagram here. Let me just first write down mu greater than mu naught. The p-value is pz greater than equal to z observed, and h1 where mu is two-tailed, that is not equal to mu naught, then the p-value is equal to twice of the probability z greater than equal to mod of z observed. So as we could see here, I have already drawn a diagram. So if it is a two-tailed, you could easily see that this is p-value would be twice of the probability of z greater than equal to z observed. Now z greater than equal to z observed means, this means that the z is lying between, we are talking about these two regions, right? This region and this region. So we are saying that the p-value is equal to twice the region. That means if this is it, we are calculating, we are just adding that particular area again. So we all know how to calculate the for the normal distribution we have already done, the standard normal variate, and how we could find out the p of z less than equal to the observed value. So this is the same one, and you could calculate it easily. So now in this case, when it is a right tailed or the left tailed, when it is a right tailed, then this is my alpha, and the whole is 1 minus alpha, right? So this is the rejection region, and the rest everything is the acceptance region. So according to this, the z must be greater than equal to the z observed value. That means the z, whatever you are getting your z, the p value would be lying in this area, the rejection area where you are rejecting your null hypothesis. On the contrary, when we'll be taking the left tail test, then this would be our z alpha minus z alpha, and this is our rejection region now, and the everything else would be same. Now the rest part is the acceptance region. This whole part is the acceptance region, and this is the rejection region. So now in this case, the p value would be z less than equal to the z observed. So whatever your p value must be lying in this rejection region. So with how we can now interpret that this would be, we are accepting our the null hypothesis, or we are rejecting the null hypothesis. So whenever the p value is greater than alpha, then we fail to reject. I'll just write it, the interpretation. Whenever if the p value is greater than alpha, then we fail to reject, or we can say we accept our h naught. Whereas if p value is less than alpha, then we reject our h naught. If p value is less than alpha, means it is lying in the rejection area. So obviously we have to reject our h naught. So let us consider a question. Find the p value for a right-tailed hypothesis testing problem with a test statistic z observed is given to us, and the level of significance alpha is also given to us, that is 0.05. So let me just draw the diagram quickly. So as it is a right tail test, so we could easily see that this would be our acceptance region. I am denoting it by AR, and this is my critical region or the rejection region. So need to find out the p value for the z statistic. Here we are given the z observed is 2.65. So the alpha is also given as 0.05. So 1 minus alpha, this is the acceptance region. So now we'll be calculating the p value. The same formula, z greater than equal to z observed. So z greater than equal to 2.65. So I can also rewrite this as 0.5 minus the probability of z lying between 0 to 2.65. We know how to calculate it, and the value from the z table I am getting it as 0.4961, which is equal to 0.004. Now also we can calculate it using the CDF, the phi hat of the value. How we can calculate it? It is by using the formula, the p-value. There are two tables in the Z table. One is for the CDF and one is for the area of the strip. So when you are considering the area of the strip, if this kind of a value is given in your exam or the table is given to you, then you can find out using this. If the CDF of the value is given to you, then you can use this formula as well. So I am writing both the formulas. So for the left tail, we know that right tail P of Z greater than equal to Z observed, which is nothing but 1 minus phi hat of Z observed. So whenever you are given the CDF of the table, you will notice that you need to calculate it like this. So this is the area from minus infinity to Z. So phi of Z is denoted by this, and Z is always less than equals to, that's the probability of Z, uh, always less than equal to small z. So if you calculate it using the table of phi 1 minus phi hat of Z observed is 2.65, again we'll get the same value. It's coming out to be 1 minus which is equal to approximately 0.004025. So that's 0.004. So the answer is same. There is no difference. Now let us consider another one where we have to find the p-value for the left-tailed hypothesis testing problem with the test statistic is given to us as minus 2.023. So here we are talking about this. So this is our critical region or the rejection region. This is our acceptance region, and the Z observed is minus 2.023. Oh, so in the previous section, the p-value is now 0.004. So as we could see here, the p-value is less than our alpha, which is 0.05. So therefore we reject our H naught. So this is what we have observed. And in this case, alpha is given as 0.01. So let me quickly calculate the p-value. So p-value is coming out to be P of Z less than equals to Z observed, because we are calculating the left-tailed. For the left-tailed hypothesis, we have this formula that p-value is equal to Z, P of Z less than equals to Z observed. And if we are finding out using the phi hat, it would be this is nothing but phi hat of Z observed, because that Z less than equal to Z observed only. So less than equals to minus 2.023. So this would be 0.5 minus 2.023 to 0, which is same as, because it is symmetric, the curve is symmetric, 2.023, and we could find out the value. That's coming out to be 0.0217. So here also, when we'll calculate it using the phi hat of minus 2.023, so the value that we are getting is 0.0216, 0.92, which is approximately 0.0217. So the answer remains the same. Now here, as the p-value is greater than your alpha 0.01, so therefore we accept our H naught. So we fail to reject our H naught. So we have a last question. The heat evolved in calories per gram of a cement mixture, approximately normally distributed. The mean is thought to be 100 and the standard deviation is 3. Test H naught and H1 is also given with n is equal to 9. So as this is a normally distributed case is given to us, so we can calculate our Z statistic here using the central limit theorem. If the acceptance region is 98.5 less than equals to X bar less than equals to 101.5, find the type 1 error. Find beta for the case in which true mean heat evolved is 103, and find the beta for the case, find the p-value if the observed statistic is given two parts. So let us start this question. So what is given to us? Let X be the heat evolved. So in calories per gram of a cement mixture, in calories per gram in the cement mixture. So X would be normally distributed. Mu is given to us as 100. Sigma square is 3 square. So this is how we represent the normal distribution. So here we are given the hypothesis H naught, mu is equal to 100 and H1 mu is not equal to 100. So it's a two-tailed alternative hypothesis as we could see here, and also we are given where n is 9, mu is 100 and sigma is 3. So this is everything which is available to us. So now let us consider the first part. If the acceptance region is given to us as 98.5 to 101.5, find the type 1 error. So let us do the first part and let me draw the diagram. So mu is equal to 100 and 98.5, 101.5. This is the acceptance region. So acceptance region is given to us, and this is the rejection region or the critical region. So now in this case we have to find out the alpha error. We know alpha is the probability of that X belongs to W when H naught is true. Now W is our rejection region. That means we are rejecting, if you don't remember, it is the probability that we reject H naught when H naught is true. So this is what is alpha error. So our W in this case is X bar greater than 101.5 and X bar less than 98.5. So H naught, when H naught is true, that means your mu is coming out to be 100. So let us calculate capital Z, X bar minus mu over sigma over root n. So I'll take this as 100, 3 over root 9, which is X bar minus 100 only. That's divided by 1. So now Z1 when x bar is 98.5 minus 100 would be minus 1.5, and Z2 would be 101.5 minus 100, that's 1.5. So therefore alpha would be P of, we could just put it here, x bar minus mu over 100 is greater than 101.5 minus 100 over uh, this is s over root n, sigma over root n, that's 1, plus p of x bar minus mu over sigma over root n, that's less than 98.5. So 98.5 minus 100 divided by 1. So that's P of Z greater than Z1, Z2 sorry, plus P of Z less than Z1. So how would we calculate this? This is coming out to be Z greater than 1.5 and P of Z less than minus 1.5. So you could see here we are talking about these two regions, and both of these regions are same. Their areas are same. So we could solve it and we will get it as 1 minus twice of the probability. So which is nothing. The final answer that we are getting it as 0.1336. So you can find out the values from 0 to 1.5. The value is coming out to be 0.4332. So after calculations, we are getting the alpha error as 0.1336. Now next we have to find out the beta error, in which the true mean heat evolved is 103. That means we know that beta error, what is beta error? Beta error states that the probability of rejecting accepting H naught when H naught is false. Or I can say that the probability that X belonging to W complement when H1 is true. So to be H1 has to be true. That means that mu is not equal to 100. Then what is mu equal to? What would be the true mean? True mean is given to us as 103. So here we are given H naught as mu equal to 100, H1 mu equal to 100 and not equal to 100, that is mu equal to 103. So in this case beta would be the probability of so as we could see this is the, let me take another color pen. Yeah, what is W? W was this region where we are rejecting. So this is nothing but the region W, and W complement is this acceptance region. So whenever you are accepting your H naught, that means we are talking about the W complement region, but with the condition that H1 is true. So here we'll be considering let capital Z would be X bar minus 103 over 3 upon root 9. That's again X bar minus 103 over 1. So when we calculate beta, 101.5 minus 103. So divided by 1 over 1, so it has no value actually, but let us just write it. So this would be minus 4.5 less than equals to capital Z. This is minus 1.5. So now after calculating this, we are getting the probability of Z less than equals to minus 1.5 minus P of Z less than equals to minus 4.5. So this is nothing but 0.5 minus P of Z less than equal to 1.5, and this value is 0. So ultimately we are getting the answer as this. This value is 0 because Z greater than equal to 4 is not applicable. So we get the value as 0. So beta is coming out to be 0.0668. Now lastly we have to find out the p values for the first case where x bar is equal to 98, and the level of significance, if it is not mentioned to us, we can take it to be 0.05. So in both the cases we can assume alpha to be 0.05. So let me just write it. So it is given alternative hypothesis is H1 is two-tailed, and we assume alpha to be 0.05. So the p-value, to find p-value in both the cases, we will be using the same formula, mod of Z observed. So in the first case where x bar is equal to 98, we could calculate Z. Z is x bar minus 100. So Z observed would be 98 minus 100, that's minus 2. So p value would be twice of probability, minus 2, that's greater than equal to 2. So that's same as 0.5 minus P of Z less than equals to 2. So we are getting it as the final answer is 0.0456. Whereas in the B part, where x bar is given to us as 101, Z is again same, x bar minus 100. So Z observed would be 101 minus 100, that's 1. So the p value in this case would be twice of Z greater than equal to mod of 1, that's nothing but Z greater than equal to 1. So this is 0.5 minus P of Z less than equal to 1, and finally the answer that we are getting is 3174. We could also calculate it using the phi hat value, and the value, the formula for that is the p value is twice of 1 minus 0.977, sorry, 1 minus, I was just writing the values there, Z observed, the phi hat of Z observed. So this is how we can calculate the p values. So now what we have achieved here, that for the A part, when we could see that p value in this case as is less than 0.05, so we reject our h naught. So in the next case, as p value is greater than 0.05, so therefore we fail to reject it, so we accept our h naught. So this is how we can find out the p values for the z test, and in the next lecture we'll be talking about the steps of the hypothesis testing followed with the z test we'll be doing in our next lecture.